Types of load. Now, types of load, the concentrated load means either single load or double load, and it is acting on a single point of the beam. Distributed load means the load which is uniformly distributed over the span. Then linearly varying load means one end of load is zero and another end is the intensity of the load is maximum. And couple means a movement you have to apply on that beam. These are the type of load, and due to that loading, the effect of shear force and bending moment we can analyze. Now, internal reaction in a beam. In suppose this is a simply supported beam, and the low concentrated load P is acting at the distance of A from the hinge support. Okay. Now the three possible internal reaction required for the equilibrium: normal force, shear force, and bending moment. Now I cut this beam at a distance of x. Now you have to see the three internal reaction. One is downward, one is horizontal, and one is the couple, because this end is basically called as a fixed kind of uh, member. Okay, okay, so there, that's why it is there develop the three unknown reaction, and same thing is an opposite direction. If this force is downward, this force is upward, and this movement is anti-clockwise, this movement is clockwise, and one force is your right hand side, another force is left hand side. Means at the end these forces are zero, because this is a balance. Actually there is no external force is applied, but when you have cut, you have to analyze the how many unknown forces are developed, internal unknown forces are developed in the beam. Now what is mean by shear force? Shear force is nothing but the algebraic sum of vertical force acting on the beam either to the left or right of the section is known as shear force at section. Okay, so yeah, I am giving some examples. Suppose this is the simply supported beam and carrying the number of vertical forces. You have to cut this section and you have to just add the number of vertical forces in a picture up to that section of a point. Now basically you are do the while you have to calculate this support reaction, you do the same thing, summation of Fy equal to 0, and you have to just calculate add all the vertical forces. But in here we have to finding out the at particular place, at particular position, what is the shear force developed due to the application of forces. That why we have to just consider the summation of forces either right or left of the section only. Okay, hope you understood. Now which kind of sign convention you have to consider? Now here I am showing the upward force and downward force. Means all upward force, if you have to consider the section from the left, you have to measure the section from the left, then all vertical forces is positive and all downward word force is negative. If you have to consider the section from your right hand side, then all downward forces is considered positive and all upward forces are considered as negative. uh, Please follow this sign convention because it is important. You have to follow the sign convention for the correct calculation or measurement. Now what is mean by bending moment? Again, the movement which causes the bending effects on the beam is called as bending moment. It is generally denoted by M or Bm. Movement means force into the perpendicular distance. Now here the bending moment means sum of the moments of all the forces to the left of the cut or to the left of the section about the point of the section includes M. Solve for the bending moment. In the same way, yeah, if I have to finding out the bending moment at a particular section, you have to just summation of all movement up to that section only. Okay, now sign convention for a bending moment. The bending moment is considered as a sagging movement if tends to bend to the beam to a curvature having convexity at the bottom as shown in figure given below. Sagging bending moment is considered as a positive bending moment. Okay, this couple create a sag, and such kind of movement is called as a positive. And similarly, the bending moment is considered as a hogging bending moment if it tends to bend the beam to a curvature having convexity at the top, as shown in the figure given below. Hogging bending moment is considered as a negative bending moment. Okay, so this kind of curvature is treated as a negative. Shear force diagram. What is meant by shear force diagram? The diagram which shows the variation of shear force along the length of the beam is called as shear force diagram. I just explained the shear force. If you have to consider, or we have to finding out the shear force at a particular section, you have to just add the summation of vertical forces, and you can say that much shear force is developed at this particular point. So it is the basically graphical representation of the shear variation of the shear force. So you can easily interpret where is the maximum shear force developed. Now bending moment. The bending moment, which the variation of bending moment along the length of the beam, is called bending moment diagram. Okay, same thing, you have to finding out the bending moment at particular section, and on that basis you have to draw the or we can say draw the diagram which gives the graphical representation of the maximum and minimum bending moment. On that basis we can decide whether we have to need to uh, make the beam stronger or improve the strength either in the shear or in the bending. Okay.